So you explain why gases react together faster at high pressure.
So at high pressure, like the gas collide like more often or frequently, right?
Yeah, why?
So it react. Uh, yeah, because the gas molecule like collide more
Frequently.
more frequently.
Why? Why
Yeah,
collide more
frequently.
frequently at higher pressure?
Uh, 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 no idea.
Okay, no ideas. So it's high P, right? High pressures.
Happy,
It
yeah.
means they close, come back,
Yes.
right?
Yep.
So collide frequently. So here, come back means stay close
Yep.
to each other, the molecules. So collide frequently. So the chance of reaction happen is higher.
Yeah.
So it's faster.
Yep.
So you miss the boy here.
Compact.
Yeah. The molecules stay closer.
Okay.
Okay, B.
Wait. Compact is like wait, what is the Vietnamese word for compact?
Vietnamese word for come back? Like gọn,
Compact.
come back. Yeah.
Oh god.
Like
Yeah.
when you put a lot of things into a very small box and it's like it's fit together,
Yeah.
like will come back. Or you can say stay closer together. High
Yeah.
pressures
Yeah.
mean the molecules stay close to each other. Then low pressure.
Okay.
Okay, B. High concentration.
Mm,
What happened? High concentration.
so if it at high concentration, so um, it increase the uh, the collisions, but
Okay. Why? Why? It's increased collision.
uh, so it's just high concentration, so it mean more collisions. Yeah, is that right?
Yeah, but can you explain a little bit why high concentration lead to more frequent collision? What does mean high concentration?
So it increase the frequencies, right?
More molecule in the same, like in a unit of volume,
Yeah.
right?
Yes.
So I mean, just in a unit volume, there are more molecules there. More molecules of reactant, right?
Yeah.
When you compare with low concentration. So in the same unit of volume, there are more molecules of reactant.
Yeah.
Moving around in that unit of volume. So when there are more molecules, there are more chance for collision. Okay?
Yeah. Yeah.
And then probabilities of reaction happen is higher.
Yeah.
So just one thing you need to remember, collision not always lead to reaction, okay? Collision, so they are like effective.
Yes.
Lead to reaction. But not like non-effective. No reaction.
Yeah.
So only the percentage of effective collision increase lead to more reaction. So only that case happen, then the solution react faster. So collision actually this is probabilities.
Yeah.
Right?
Yes.
Okay, C.
See, explain why. Explain why. Can I have time to think?
Yeah.
Okay. Finally divided solid.
An idea?
So lump, solid lump is mean like in the same in the fixed position, right?
Lump is like big
Yeah.
solid. It's like
Yeah. Okay.
bulk.
Oh. Wait.
Or maybe
Wait.
bigger.
Uh, finally divided
So here you might see
solid
like some
react
things, yeah.
because the particle is moving freedoms
Wrong.
because it has more space, wrong?
Not more space, but more surface area.
Oh, surface area. Okay.
So
Okay.
phi is like divide
Yeah.
solid particles. Like more like bigger surface.
Yeah.
Okay.
Yeah.
area.
Bigger surface area. Okay.
So for a reaction to happen,
Yeah.
in fact, what important is like more active site.
Yeah.
So I mean more interaction.
Yes.
So more interaction is mean higher probabilities for a reaction to happen. Get it?
Yep.
Okay, D.
Uh,
While raising the temperatures increases the rate of reaction.
raising temperature increase
Yeah.
rate. Mm.
Increase the rate of reaction is mean reaction faster.
Oh,
Right?
so it increase the energy
Okay. What kind of
energy of
energy
the
it is? Kinetic inner
kinetic energies
energy.
of the reactant.
Yeah, energy of the molecules
What? Oh, reactant molecule. Okay.
or reactant, you can say. So more energy is means it's move faster, right? Move, vibrate faster.
Yeah.
So chance for collision, for effective collision is higher.
Yeah.
Higher. So reaction happens at high rate. That clear, reasonable? What do you say?
Yeah. Yeah. It's okay.
Oh, good. Okay, so by this way, you can check your knowledge.
Okay.
This is how you're going to check your knowledge.
Yes.
So you know how to check, right?
Yeah.
Check yourself, your knowledge for each chapter. And you can tell, okay, I get it, or I don't. So you know like level of your understanding. See, maybe the teacher already covered this chapter, but there are things that is not clear to you, right?
Yeah.
And then you can come back and review. Okay, review, revise, whatever. If you need it. So by this way, we learn. For the first time, maybe everything we forget. But for the second time, the third time, the fourth time, we remember more. Remember and then understanding.
Yeah.
That different for you? Remember and understanding?
Yeah. It's different.
Okay. And the target is understanding. We remember information, but we need to understand also.
Yeah. Okay.
So why we need to know, okay, when the reaction happen faster, slower, when? Why we need to know this kind of knowledge?
To have a so basically
Why?
to have a uh, like to have some knowledge first, and then we can apply it to sum up harder questions, right?
No, so that we can control it.
Oh, control. Okay.
We can control.
Yeah.
I mean, okay, I want it faster, or I want it slower.
I want.
I want the reaction to happen faster. What did I do? If I want it to keep the reaction happen slowly, what can I do? You see?
Yeah. Okay.
So this is what happened in industry. So in industry,
Yes.
so industry, suppose like people produce like ammonia or any kind of chemicals. Okay,
Yes.
maybe some medicine.
Yep.
So if they can control, they can change condition, so they can get higher yield. Use purities, you know,
Yeah.
and then the cost, like energy, selection also. Some reaction it happen and give out many products, and we just want one or two kind of products,
Yeah.
and then we need to control the condition so that we get the product that we want with high like qualities, and then high yields with the lowest cost, so that people can sell or more people can buy the product.
Yeah. Okay.
Get it?
Yeah.
Okay. So for that part, we're going to finish the chapter 9. Now we start with chapter 10.
Yeah. Okay.
So in chapter 10, we learn about periodic table. So periodicity. So what does this word tell you? Periodicity. It's a repeat, something like repeat, right?
Yes.
Pattern. Something happen again and again and again.
Yeah.
That we call periodicity. Okay, so what we learn about periodic table, and then the periodicity of physical properties and then chemical properties. And then we look in some oxides of period 3 elements, effect of waters on oxide, hydroxides, chlorides, effect on. So this one is like period like period 3. And then other people learn more about other elements. So there are a lot of elements in the periodic table. Sometimes people just spend the whole life to learn a few elements.
Yeah.
Okay, this is periodic table of element. It's modern version.
Yeah.
right? So see there are different colors, and then you have the different column here, and column we call yeah, group, and then the horizontal, the cross row we call barriers.
Yes.
Okay, and then you see the materials, the element here like arranged in different like in an order, different colors, so it reflects something, reflect the materials, the qualities, the properties, sorry, physical property and chemical properties.
Yeah.
So periodic table is like a map. Okay, it's like a map.
Yeah.
Map of element. So it's E at E to learn, to predict. Okay, to learn, to predict, to controls.
Yeah.
So it means to simplify chemistry, so that people can learn, people can keep track of information, things. So this is in your like about like 100 years, 150 years before,
Yeah.
and this is the old version.
What?
And his
Okay.
name here like Mendeleev, a Russian like scientist. And he made a great contribution, like put the element in an order that we still use it today. But you see the difference here, like H here, there are a lot of different things here. You see like hydrogen. You see he put the first column here, the noble gas. You see noble gas here. Today is outside here.
Yeah.
But he already did like the great contribution. People remember him for his big work. Okay, so the modern periodic table, you see group, so it had like 18 group, 1 2 4 and then 18
Yes.
18 group, and we have 7 barriers here, barriers 7 6 5 4 3. So in this chapter we learn a lot about chapter 3, like sodium, magnesium, and aluminum, silicon, and phosphorus, sulfurs, chlorines.
Yeah.
So look at the number here, number 111A, right? So it's 11A element, right? 18 group,
Yeah.
7 barriers. So how the symbols or how the element is arranged. So hydrogen, you have number 1 here, helium number 2, lithium number 3, 4. So what the number tell you? It's
Sorry.
what these number tell you.
Where?
See,
Oh,
like 3 lithium. You see lithium?
yeah, 3.
Okay, so what is number 3 indicate? What it tell you? What does it mean?
Wait, it's just the order.
No, it's atomic number.
Oh yeah, atomic number. Yeah. One, two. Okay.
So it's atomic number. So you see atomic number, atomic symbol, name,
Yeah.
and then mass element. So element arranged according to atomic number, right?
Yeah.
So what is atomic number?
What atomic number?
Yeah, what is atomic number?
Um, it's just a proton.
Proton. Yeah.
Yeah, the number of the chemical elements.
Yeah, atomic number. Yeah, that's right. Atomic number is the number of proton. That's good. Okay, let's see. Question. Look at period table. Which element is found in period 4, group 17? Period 4, group 17. Period 4.
Yeah.
This is period 4, right?
Yeah.
Group 17 here. So it's bromine, right?
Yeah.
Yeah. Here like bromines. So relative atomic masses of telluriums and iodines are like 128 and 127 respectively. Why did this present problem to Mendeleev when he was constructing it were here?
Yeah. Okay.
So the atomic mass is very close to each other, right?
Yes.
128 and 127. So it's problems for him. It might be hard for him. Why do you think? Like 128, 127.
128.
Yeah.
Where?
Here.
Oh.
Atomic mass. So you need to check the tellurium and iodines.
Yeah. Okay.
So here like iodine here.
Yeah.
Here tellurium, right?
Yeah. Yes.
Okay, so if stay very close to each others, the mass.
Why did this present a problem?
So why this present a problem to Mendeleev when he was constructing his period table?
Maybe he just wanted, because he just wanted in the orders.
Okay, in my opinion, it's because they stay in two periods, two groups differently.
Yeah.
Okay, good. Why are elements in group 1 and 2 known as the S block, and group
Yeah.
17 is called B block? Get it?
Yeah. Yeah.
Group 1 and 2 here. Like S block. And the other ones, B block 17.
Yeah.
So this is how they arrange the electrons. So the electron is in group 1 and 2. Most stay in s orbitals.
Yeah.
See, for example, lithium, lithium, how many electrons does it have? 3, right? So 3 is like 1s1. 2 s1.
Yeah.
So the electrons stay in the orbital s. That one we call s block.
Yeah.
Similar, you can try with the magnesium or beryllium. Up to you.
Yeah.
Okay. Now we look at the physical properties.
Yeah.
So physical properties. So the first thing we look at a atomic radius, I mean the radius of atoms in the buried tables. We have a pattern for how the atomic radius change
Yeah.
within the group or within the barriers like this.
You can compare size.
So it's
Okay.
covalent radius, right? So look at
Yeah.
this buried 3 elements: sodium, magnesium, aluminum, silicon, phosphorus, oxygen, uh, chlorine, sorry, and argons. So see the atomic radius change. It's like the biggest here and the smallest there, chlorine. So you see the atomic radius decrease. Okay. Where is pattern of ionics are ready. So you see here like ionics different with their atomic rays, okay?
Yeah.
So difference from atomic. So the ions radius, the radius of ions, it can vary. It can change, increase, or by decreasing. Okay, and you see here the graph showing atomic ionic radius and atomic number. So high atomic number, high ionic radius.
Yes.
Good.
Yeah. Good.
You understand the graph?
Yeah.
Okay, excellent. There is a pattern of melting point and electrical conductivity. So first we look at the size of the atom, and now we look at the melting point and electrical conductivity. So melting point, you see melting point here like sodium, melting point here. Sodium like 371 and magnesium like 728, 23. But chlorine is reached 172. So this one is very high temperatures.
Yeah.
This is one is very high temperatures. Melting points are okay. Then electrical conductivities, you also see is increasing or decreasing. So increasing to silicon. Okay, electrical conductivities.
Yeah.
Electrical conductivity. So this one is very high. Aluminum is higher even. See this one is high. That reason why we use it for electric wire.
Yep.
Okay, the last thing we look at the bonding type. So you had metallic, and if you read more, you see more giant metallic, giant metallic, and then giant simple molecular. See the kind of bonding happen here, like metallic here, and then covalent here. Simple molecule giant, so different kind of excitant like structures. So even in the same barriers, the elements show different property, and we can explain it into based on the properties of the element. So see the pattern of properties like this one. A reason people put the element of chemicals in periodic table. Okay.
Yes.
Here we have melting points and atomic number.
Yeah.
So the silicon is very high, right?
Yeah.
So there are questions we can ask, like why does sulfur have lower melting point than silicon? Like sulfur, you see sulfur here, and silicon here.
Yeah.
So it depends on the kind of bonding. For example, the sulfur is had covalent and not a sign. So in bonding, sulfur and silicon are the same covalent, right?
Yeah.
This one, but the structure is different. In silicon, it exists as giant molecule, but in sulfur, it's simple molecules. So simple molecules, the bonding not strong with each other, so easy to move away. Like these molecules move away from another, so turn into liquid. But giant molecular, the bonding is very strong inside. It's extra at the like crystal. So atom it bind to another one strongly. Very hard to get out of the network. So that is reason why sulfur melting point of sulfur is lower than like silicon.
Yes.
Okay.
Yeah.
And in a similar way, we can explain compare like chlorine and sulfur. It also depends on the bonding, intermolecular bondings, and intercellular, crystals. Why magnesium is better electrical conductor than phosphorus, sodium? So magnesium, electrical conductivity of magnesium here. Magnesium, we have magnesium here. We have phosphorus, sulfur. So magnesium electrical conductivity like 0.224, where phosphorus is very small, right? Very small. So it doesn't conduct electricity at all. So look at the bonding. You see, like in magnesium, it's metallic. In phosphorus, it's covalent. So in metallic, you remember like metallic bonding?
Yes.
The electron is free to move around.
Yeah.
But in covalent bonding, the electrons stay in the bond, so no electrons will move around. That's the reason why electrical conductivity of magnesium is strong. It's better.
Yeah, okay.
Good?
Yeah.
Any question?
No.
Okay, what do you know about like ionization energy? What is ionization energy? What is FERT? What is this? Can you tell?
Sorry?
Can you tell me what is FERT ionization energy?
First ion. Uh, Wait, so the energy that like uh energy like remove from the outer
Huh?
outer layer.
Can you say?
Uh, like the energy that need to remove something.
Remove
Yeah, I
electrons.
forgot the.
Remove
Oh
electrons.
yeah.
The first electron, you see this one?
Yeah. Yes.
So gas here. So energy required to remove the first, okay, the first electrons. I mean the outermost, I think.
Yeah.
So for some, the energy is required very high, for example, argon or chlorine.
Yeah.
But sodium, magnesium is low. So this is easy. I mean, for sodium, it's easy to get to lose electrons. The first electron. For argon, very hard. So that reason why argon is very stable.
Yeah. Okay.
Or we call it like inert. This one is very reactive. But easy to give electron out.
Yeah.
So for chlorine, it doesn't give, but it can accept. Design.
Yes.
Can accept electrons. But sodium reactive, give electrons easily. So chemical reaction, in fact, it just move around electrons. So chemical reaction, in fact, it just move electron around. So it's just weak one give electron, weak one get electrons. Let's say. So first ionization energy tells us a lot about this.
Yes.
Ions, so ions can be positive or negative, right?
Yes, that's right.
This is trend for ionization energy. So why with some like element the first ionization energy very high and for others low? Why that?
Sorry, can you repeat the questions?
So why the first ionization energy of some element is very high, right? Some others low, very low, or quite low. See, if you compare argon with sodium, first ionization energy of argon like 3 times, almost 3 times of sodium, right? 3 times higher. So why there is the difference?
Because it increasing the number of protons.
In this barriers,
Like,
in this barriers,
but no.
in the same barriers, right?
Yes.
The same barriers, it means it doesn't increase much layer of electrons, same number of layer of electron, right?
Yeah.
So the shielding is not strong, but the force. So I mean here the nucleus here keep electrons tightly.
Yeah.
These atoms keep electrons tightly. That's the reason why demand high energy to remove. So in fact, it's just the force. Between like nucleus and electrons. That's the difference. That made the difference. Remember, it's the same pairs, okay? So have the same number of layer, right? You get it?
Yeah, I get it.
So bear 3, it means like 3 layer. So look at this one, you see like sodium 11, magnesium like 12. 11, magnesium 12, like that. You remember the layer of electron, right?
Yes.
Good. So what is the general trend in first ionization energy cross period 3? The trend already you see in the graph here, like increasing. That general trend increasing from the first element in the barrel to the last one. Explain why aluminum has lower first ionization like magnesium. Magnesium and aluminum. So this one is going up and down, like up and down. What do you think is the reason?
Up and down.
I mean, the first ionization energy of sodium, it increased to magnesium and then it dropped, right? And then it go up again. So for the question, you need to write out the electron configuration and see.
Yes.
So this one, you need to write the electron configuration of aluminum and magnesium. Why sulfur has a lower first ionization energy in phosphorus? Okay. Sulfur and phosphorus. You see here, like up and down again, like up here and then down. And then look in period 4. Period 4 we have gallium, germanium, arsenic, and first ionization is a p plot element are given table.
Yes. Okay.
So see this one, selenium here. So here with number should be here, right? So increase slowly, yeah?
Yeah.
So it should be somewhere in the middle between like maybe it's around like 1000. So we use the periodicity to to predict. First we arrange it so that we can remember easily, we can learn easily, we can and then another thing that we use to predict the values information when we don't know. Look at the trend, based on the trend. Okay?
Yeah.
So this one is maybe the average values. Of 966 and 1140. It should be in the middle, right?
Yeah. Which one of these?
You understand it?
Yeah.
So this one is just check information. So we don't think it, right? So you can check the melting point.
Yeah. Which one of these correct?
Check the melting point, check the bonding, check the ionic radius. For example, this one we already see it. So let's see, check the C, ionic radius. Okay.
Okay.
So let's see. Ionic
Yeah.
rays. This one is not. This one for ionization energy. This atomic number and melting point. Ionic rays here, right?
Yes.
So it's decreased slowly, right?
Yeah.
So that is correct. Decrease or increase?
Decrease.
The decrease here is decrease
Yeah.
and decrease until here, but then increase. You see increase
Yes.
and then decrease and then decrease. So something wrong here.
Increase, decrease. Yeah. And
So
then it
based on that,
increase.
we can answer the question. So here they say decrease steadily. No.
Oh. Okay.
See?
Yes.
So we just
No.
check information.
Yeah.
Let's see, check D. Structure of element change from metallic in group 1, 2, and 13 to simple molecular in group 14 and 17. So here like metallic and simple molecular. So look at structure here, right? Structure and bonding. Look at the bonding. Metallic, covalent bond, covalent in phosphorus, sulfur, chlorine. So aluminum back is metallic. Silicon is covalent. So we can see here with this one, for example. So here like group 13, right? Aluminum.
Yeah.
And after aluminum, silicon, phosphor, that is simple molecular. But before is metallic. This is correct.
Yeah.
So metallic from group 1 to 13 and simple molecular in group 14 to 17. Is that correct? Right?
Yeah. Yeah. Yeah.
So
Yes.
that is how we think have inform exercise just help us to see the pattern, see the trend.
Okay.
So after a periodicity of physical property, we're going to see the chemical property also has some trend. So for the trend, normally we check by let the element react with the same reactant. For example, in this case, with chlorines. So what happened like this one with chlorines? You see, we compare sodium, magnesium with chlorine, aluminum with chlorines. This is react vigorously. Okay.
Yeah.
This one is vigorous reaction also, but this one is slowly with chlorines. So you can see
Yeah.
that this one it does not react. So like the reaction like happen, is reduced, decrease. The reactivities of the element in the barriers, it like decrease. See that? So here you see vigorous, slowly, then no. See?
Yeah.
So that trend,
First, slowly.
no reaction at all. See?
Yeah.
So I mean the way people put the element into a periodic table, correct? It shows the trend. So here is sodium like react with water. It's very reactive. See? This one like sodium and waters. But if you put magnesium, extremely slowly.
Yes. Fresh magnesium reaction.
This one is like vigorous.
Well, it takes several days to
Mm,
produce. Oh, the picture is vigorous, right?
yeah.
Oh, okay.
So that also shows the training chemical property too. So the kind of question like help to remember. So there are kind of question like help us to remember to check if we know information. Yeah. But their information is we need to think. Think is mean a connection between different ideas. Help us to solve problem. For example, this one normally it's just like remember things.
Yes.
Lithium reacts in a similar way to sodium, react with oxygen, producing lithium oxide, including state symbol for this reaction. So if we go
Yeah.
like lithium and then react with oxygen, we get like L2O. So this one normally is solid, this gas, and this one is solid. So we can put like 2 here and 4 here. Let's see. Let's see, we do have here. No, we don't. Okay. So lithium also react with chlorine. So we see like chlorine, sodium, chlorine, like sodium chloride. So if you put
Yes.
here, you see like lithium,
Lithium plus chloride.
right?
Lithium plus, yeah. Wait, where is the two?
To where?
The two in the product.
Lithium chloride here.
No, no, it's okay. Okay, okay.
So if you want, you can put it here and then here, right?
Yeah.
That's to balance.
Oh, okay.
And like option B, group 2 metal calcium. Calcium react with waters. And then it form alkaline solution.
Yeah.
And that's.
Oh, okay. Yes.
Maybe we need hydrogen also. So I put it here. This one is creates hydrogen.
Yeah.
Then the last one is that calculation. Magnesium. So we compare calcium react completely with uh, waters.
Yeah.
is it's more unclean. You
Yeah.
understand why it's more unclean?
More alkaline. Just
Okay,
like
what does it
like
mean?
so just put more alkalines.
You understand this one? You understand the problem or not? Thus, see this one?
Yes. More alkaline dissolutions.
Tell me what the question is. Understand the question or not?
I understand.
What does it mean more unclean?
Uh, more alkalines.
So you don't understand.
Yeah, I'm not sure with my
Okay.
answer.
So more unclean means BAs is higher. Okay? Or it's mean like more basic.
Yeah. But so if it more acid, so the pH is lower
Yeah.
and less basic. Okay.
We already learned
Yeah.
the BH scale, right? So what the question they ask, what does ask you? So I mean, in this question, you don't understand one word, right? More alkaline. Then you're not going to understand everything. You get it?
Yeah.
So only one term we don't understand, then it can like stop us from understanding the whole thing. So the question asks, in calcium and react with waters, it creates calcium oxides. And similarly, magnesium waters creates magnesium, right?
Yes.
So they ask the same for the this one the same. And this is like 1 moles. This one later, I think. But this is more
Yeah.
alkalines. Why is that? You can look at this one. This is slow reaction. But calcium will react faster. And the other things is slightly soluble.
Yes.
Get it? So first,
Yeah. Okay.
this one is slow. And only is like a little of OH is released into solution. Why? This one is faster and more OH in solution.
Yeah.
Because both react completely. Okay.
Yeah.
Any question?
more OH in the solution. No, okay, that's fine for me.
Fine.
Yeah.
I mean, after you learn with me, you see that you understand better or not?
Yes, much better.
Okay. Yeah, I'm happy to know it. Okay, I'm happy to know it because it must be meaningful to you learning with me. Otherwise, it's just like waste of time and money. See? So it should be useful. And when you learn with me, it should be helpful to you. So in the case, if it's not helpful, you don't understand it clearly, you tell me.
Yeah, okay.
Okay, like that? Agree?
Yeah. Okay.
Good. So I see you tomorrow.
Yeah.
So tomorrow we continue this chapter and finish.
Yeah, okay.
Okay.
Yeah, see you tomorrow.
Okay. Feel good?
Okay, goodbye. Yes.
Okay. Bye bye, Tai.
Bye. See you.
Okay.